Okay, welcome back, guys. So today we're going to be talking about secant and tangent lines. So let's bring up the notes here. So today we're continuing our review, and we're going to remind you what a secant line is and what a tangent line is. Now, a secant line and a tangent line are different than the functions secant and tangent from trigonometry. A secant line intersects a function in two places, and I've always remembered it as secant sounds kind of similar to secant. So two places, secant. Secant means it intersects a function twice. Tangent line is a line that intersects a function in one place. One way that I've kind of always thought of the tangent is, let's say that we have some function that represents a conversation. So like that's a conversation function, believe it or not. If you go off on a tangent, it means that you're talking about something that is related to the original thing in only one spot. So like here, and then going off on a tangent means that you're kind of drawing a line that intersects that original function in only that one spot. Whereas a secant line would intersect the original function in two spots. So like this, secant line. And this is local, of course. This function here, or this line, would end up intersecting it again. But locally, this would be considered a secant function if you only look at that one section. Same thing with here. This function would probably eventually cross, or this line would eventually cross this function again. But since locally it only crosses at one point, it's still considered to be a tangent. Okay? So the main thing about secants is the closer you bring these 2 points together, let me kind of draw another function here. All right, that's still not great, but if I start out with this function here, or these 2 points and the line between them, the closer I bring this other point to the first one, the closer this is going to approximate a tangent line. And tangent lines are important because they tell you the instantaneous rate of change of a function at a point. So let's talk about finding the equation of a line secant. So in your Delta Math for the week, you have 3 different types of problems. You have one where you're given a function and you need to find just the slope of the secant line between x equals -5 and x equals 3. So essentially what you need to do is just find the 2 y values that correspond to this. This is really like an Algebra 1 problem. And the reason it's that is because we're going to turn these into 2 xy coordinates. So one coordinate is going to be -5 comma something, and the other coordinate is going to be 3 comma something. If I want to find out what goes with 3, let's do that first. So this is going to be -3 squared, so that's -9. -6 is -15. -8 is -23. And then if I put in -5, -5 squared is 25. Negative that is -25. So -25 plus 10 is -15. -15 minus 8 is -23. So to find the slope, I'm going to do y minus y, which is 0, over x minus x, which is 8. And if 0 is in the numerator, then the slope is 0. If 0 is in the denominator, then it's an undefined slope. So 0 in the numerator means this has a slope of 0. Okay? So that's one type of question you'll have to do. And this is, like I said, it's really an Algebra 1 question. But since it has to do with secant lines, we're covering it here. So the other kind is secant lines numerically. So you'll have to do a few different slopes here. And I'm actually going to be using the Delta Math calculator for this because I don't have my calculator in front of me. So it's asking, we've got this function, f of x is equal to x squared minus 7x plus 2. We want to determine the slope of a secant line of f for each of the intervals. So we want to go from x equals 6 to x equals 6 plus whatever h is. So if h is 1, that means the 2 x coordinates we're looking at are 6 and 7. So we've got the point 6 comma something, and then the point 7 comma something. And as these 2 x values get closer to each other, we'll be closer and closer to the slope of the line tangent. So if I substitute 6 into this function up here, I get 36 minus 42 is -6 plus 2 is -4. If I plug in 7, I have 49 minus 49, which is 0, plus 2 is 2. Now to find the slope between these 2 points, 2 minus negative 4 is 6, 7 minus 6 is 1. So that means the slope between those 2 points is 6. And I'll get to why I'm using the calculator here in just a second. Now for the next one, we're going from 6, which I already have the values for, so I don't need to erase those, to 6 plus 0.1 on x. So 6 plus 0.1 would be 6.1. And now I need to find a y-coordinate to go with that. And here's where the calculator comes in. So I'm going to type in this value. I've got parentheses 6.1 parentheses squared minus 7 times 6.1 plus 2. And that gives me negative 3.49. So now finding the slope is going to be a little more difficult because I'm dealing with decimals. And I know you guys love decimals. So negative 3.49. So again, to find the slope between these 2 points, I'm going to do negative 3.49 minus negative 4, which is positive 0.51. 6.1 minus 6 is 0.1. And so this becomes 5.1. So then, okay. Now the next one here, I have to do it now for 0.01 and 0.001. So let's walk through that. Again, the 6, negative 4 doesn't change, but the other point does. So the other point is going to become 6.01, comma, whatever I get. And then I'll have to do it again for 6.001. So I'm going to take this, and I'm pretty sure I can copy and paste it. Haha, I can. So 6.01, and then this is 6.01, and I get negative 3.9499. Now if I do negative 3.9499 plus 4, and then whatever that is, so 0.0501 divided by, what is it? The distance between them would be 0.01. And so I get 5.01. And no credit if you can guess what the next one would be. But we're going to find out for realsies. Oh gosh, I can't go back up. All right, that's frustrating. So next is 6.001. So parentheses 6.001 squared minus 7 times 6.001 plus 2. So I get this number. And now if I do negative 3.994999 plus 4, and then that divided by 0.005001 divided by 0.001, I get 5.001. Haha! Aren't you glad I made you actually go through that with me? Even though I'm sure some of you in your pattern recognition brains could have figured that out ahead of time. So what this is showing is as we get a point that's closer and closer to 6, we're getting closer and closer to approximating what the slope of the line tangent at 6 is. And this is what calculus is we're taking smaller and smaller intervals to try to estimate what something is instantaneously. So I'm going to submit my answer there. Cool. Now there's one more kind of problem that's on this week's assignment, and that is slopes of tangent lines. And I saved this for last because it's actually the easiest. At the beginning of the year, I would have made you find the slope of the line tangent by using the difference quotient. I don't know if you guys remember that or not, but the difference quotient is f of x plus h minus f of x divided by h, and then evaluate that at x. And you don't have to do that because you guys already know, or should, hopefully, remember that the slope of a line tangent can be found by taking the derivative and evaluating the derivative at that x value. So first find the derivative. So f prime of x, in this case, is 10x minus 3. And then evaluate the derivative, f prime, at the x value you're being asked to evaluate. So that would be 100 minus 3, which is 97. So that means the slope of a line tangent at x equals 10 is 97. So there you go. So that's what we're doing this week. Send me an email or a Google Hangouts message if you need help. I'll be around. Otherwise, yeah, I hope you guys have a great day.